Welcome to the second series of the Lanfrica Talks. We're your hosts, Jane, Joroge, and Samuel. Today's speaker is Perez, who will give us an exciting talk about building African voices. Perez Ogayo is a master's student at CMU in the Language Technologies Institute, where she is focusing on low resource natural language processing. Her interests in NLP are multilingual machine translation, speech synthesis and recognition, and NLP for endangered languages. She is also a researcher at Masakani, working on Luo and Kiswahili. Perez, the floor is yours.
Hi, everyone. Thank you very much, Lanfrica, for hosting me. My name is Perez, and I am a master's student at CMU. Rising second year. I'm doing my master's in language technologies, and today I'll be talking about a project that I've been working on since last year, which we published called Building African Voices. For a bit of context, I am Kenyan. I was born and raised in Kenya, and I did my undergrad in Rwanda, and then moved over here for my master's. So thank you so much for all who have joined to listening into the presentation. I'm also very excited about this presentation because it's the first time that I am talking about this work after it was accepted at InterSpeech. So this is a very special moment and day for me. And I'm glad that you guys are here to listen, and also for those who are going to listen in the future. So during the presentation, I would like it to be as engaging as possible. So feel free. I don't know how the moderators are going to organize it, but yeah, I would prefer if people could just like ask questions, but maybe that might not be like the best way to run it. So Jen, I think you can advise on how you're going to do that. Otherwise, I'll be happy to answer all your questions at the end of the presentation. How are we going to do it, Jane?
About the questions, Samuel and I, if you have any questions, you can post it in the chat, and then at the end of the talk, Perez will answer your questions.
All right. Okay. Thanks. So yeah, without like wasting much time, I'll just go straight into the talk. So yeah, as I mentioned, it's my title of our project was Building African Voices. And it was started last year when I joined CMU, and I did it together with my advisors. Alan Black is we just retired from CMU, and Graham Newbeck, who is now my continuing advisor. So for our goals when doing this project was to build a high quality speech synthesis corpora for African languages, and at the same time enable others to build speech systems for African languages with minimum technological resources and subject matter expertise. And I think I'll talk about why these two are important. So I think we've seen like a lot of people putting in a lot of effort in trying to cover or include African languages in language technologies. We are still not yet there. Like a lot of languages, African languages are excluded in some of these technologies, and we have amazing work from amazing Africans and other people who are doing good work to change this status, and a special shout out to Masakani. And all the members of Masakani were kind of leading this from the grassroots level. So I think when you talk about like language technologies, they're like different medium. We have text, we have speech, like as a form of like language, how people communicate. And mostly we see most of the effort going towards like textual, but with speech, there's like very little, there are less like efforts towards speech, and there's like little speech, speech data sets out there. I'll also like to give a shout out to Common Voice, who are doing a good job to in building African data sets. They're really, really like done a great job, amazing job, and they're continuing to do a good job. So within speech, there's text to speech, which is also like there are even less data sets for text to speech that can be used to train text to speech models. Like you would find maybe a good number of like data sets for ASR out there for automatic speech recognition, but there's very little like high quality data. And high quality data is really important for speech synthesis or text to speech. And for the second thing about like enabling people with minimal technological resources and subject matter expertise, I think when you're talking about African languages and enabling Africans to be able to take part in this, most Africans would currently they don't have like a lot of like technological resources. They don't have like the powerful many GPUs, and many are still like learning and upskilling. So like what's the easiest way that you can help people to be able to build speech systems from their phone or from their like computers that don't have like powerful GPUs? So this is summary of my work. We're going to just talk about like speech synthesis. I'm just going to briefly talk about it and then contextualize it in Africa, and then talk about the project and future work and opportunities for collaboration. So yeah, I've talked about speech synthesis. I don't know how many of you are already familiar with speech synthesis, but this is just like a very shallow overview of it. So it's also known as text to speech. So it's the process of generating spoken language by a machine on the basis of written input. So when you give your computer, like for example, on the picture, hi, you'd want your computer to be able to say hi. So I'm sure like many of you have interacted with some form of text to speech. I know currently a lot of people are using TikTok, and it's very popular on the platform to hear like speech generated by TTS on TikTok. It's also used in transport systems. I don't think I got to experience this back home, but I think when I moved to the UK and the US, a lot of it is used there, and digital assistants are like of Siri, Alexa, when they actually speak back to you. It's useful in translation interpretation, and it's very like really, really important for unwritten languages. And I think a good number of African languages are unwritten, so they don't have text, they don't have like a way of like writing it. So if we maybe invest in speech technology for such languages, it would be better. And it's also like important in low literacy situations, especially in Africa. We have regions that have like low literacy levels. People don't write, but they can speak their languages. So if you can like develop technologies that enable people and computers to interact with them via speech, that would be like very useful to them. For those who can read and those who can't read speech, most can communicate via speaking and listening. So to generate a text-to-speech system, a TTS system, there's like just like a general overview of like what kind of goes on to the entire process of like generating a speech, like building the model, and then like from the model, like getting the speech. And this is not like written on stone. I think there are different methods, and nowadays like we have deep learning methods which don't have to go through every single thing that is out here, but it's just like an overview. So one like really important thing when you're talking about like data sets for text to speech, it's like the difference between the data that is like ideal for text to speech and data that is ideal for automatic speech recognition. So ASR is now when like speech recognition is like when the computer is like understanding what you're saying. Like, for example, when I'm talking and then we have the captions, that is like ASR. And then TTS is the reverse. So TTS, you give the computer text and it gives you speech, but ASR, you give it like a speech and you're given back text. So mostly there's a difference in the kind of datasets that you can use that is ideal to be used for both of them. So for TTS, you mostly require a single speaker, and for ASR, the best if you get a dataset that has like many speakers, that would be the best. And then for TTS also, we require very little background noise, a little variation. And then for ASR, you need as diverse settings. So when you're in a car, when you're in a large building or in like a place with a lot of noises, so you need to collect data from different settings and like variations and accents as possible. And then but I think I wanted to mention like currently like there are a lot of like TTS techniques right now that can work with multi-speaker data sets because of advancements in the field. And then speakers for TTS who develop TTS data are usually like highly trained. So these are people who have gone to the studio before, people who maybe most of their work is like talking and being recorded. So they're used to speaking to a microphone. And yeah, they're not like new to like being recorded while speaking. And then for ASR, you need like people with different backgrounds and in different recording like experience. So it's not a requirement. You actually need as many diverse types of like people as possible. Yeah. So to just talk about like speech synthesis for African languages. So as I mentioned earlier, there's very little work for slightly above like 2,000 languages in Africa. I'd like to mention that there's a lot of work done on the South African languages, 11 official South African languages, and this is mostly because there's a joint effort from the government agencies to try and like document them and build language technologies for them. And then there's obviously more work on ASR, collecting ASR data, building ASR models than TTS models and datasets. So just to mention some, these are not all of them. These are like some of the existing work on text-to-speech datasets. The first two, I think, South African, and then we have Gamayon for Kiswahili, and then we have another Kiswahili. The others, I couldn't put all of them here, I'm just mentioning them. And then there's ILSTI has like free synthesizers that are available. And then we also have like found data, which I think I'll talk about later in more details. So these are like recorded speech that you could use. So in African languages, you have the CMU Wilderness Project, we have Common Voice, Gamayin Open Bible, Bible.is, and then we have commercial synthesizers. So Microsoft has some African languages, Google has some. I think Microsoft has more than Google. And then we also have Ajala AI and Inclusive Solutions. So these obviously they do sell them, and you need to, if you wanted to use them for like large projects, you need to pay. Yeah, so I'll go into talking about the paper. So first, why is building African voices really hard? That's because like there's little data. It is hard to access recording equipment, and that's in two ways: funds, and like, okay, you need some money to either buy them or rent them, and then also availability of the recording resources. So if you're in an area where you don't have access to a studio, it might be difficult. Literacy levels, as I said earlier, people usually record like good quality data sets for TTS, usually like are kind of people who are literate, they can't read. So for some languages, it's hard to find people who can read. And then also of course, we have like endangered languages on the continent, and it difficult. So for some of those endangered languages, it's really hard to find people who are fluent in those languages. And then also like multilingualism, in the sense that like a lot of African languages exist with like other languages. So like, for example, in Kenya, I speak 3 languages, and that does affect in a way like how fluent I am in the 3 languages, and like how do you like speak them. For example, like an everyday Kenyan will probably mix the 3 languages that they speak. For example, I'll mix Luo Kiswahili um and English when I'm speaking. And that like when building a TTS model, it's really, really difficult when you're trying to do that, because you're like, okay, what's English? What's like words do I include, or in English, like the kinds of like context switching and all those things. So it's a bit more difficult to like get data and the right mix of data. And for example, like how do you pronounce stuff? Do I use like, cause for example, I am a Luo, so like I'll pronounce fish as fish. So like, do I, when you're building your TTS, like how do you want that to happen? Do you want your speaker or their recording, do you want them to say fish? Because that's how it's spoken, how it's pronounced in English, or like fish, because that's how like Luo will pronounce fish. I did is fish. Yeah. So yeah. So for this project, we wanted to like, yeah, we want to like build this asset, but we also want to enable people to do it, either for their projects or just to contribute so that others can use. So our philosophy is just basically like trying to um, uh, enable as many people as possible to be able to do it for themselves and like for the projects that they're interested in. And this we borrow from a lot from like Masakane and what drives Masakane. So yeah, 3 main things that guide us. Accessibility, and this is really important because people ask a lot of questions after reading the paper. Why did you choose to use Fastfox or Flight instead of like, oh, like the new like Tacotron or some deep learning techniques? So one of the reasons is because of accessibility. For all the methods or techniques that we used, you could easily use them without having like access to powerful like computers, or without like understanding like a lot about like the planning and stuff. Because there's like a nice interface that somebody can easily follow. And then also with CMU Flight, you get back the model in a format that is ready to deploy. So you could just finish training it and just like download it on your phone, and you'll be ready to use it on your phone or on your computer. So there's nothing else that a user needs to like do to kind of like make it work. It's almost like ready to use once you're done training. And then another thing was like quality. We try to create the highest quality possible we can with like the amount of like money and access to like equipment that you have. And then breadth, we also try to cover as many languages as we can. And then we do that in 2 ways. We use sources that are already there. So like if you find found sources where like these are data that are already there that people have recorded. So for example, a lot of recordings from the Bible. For most African languages, if you want to find like good quality CD recorded audio, you try and look for like Bible recordings. So we use such like sources, and we also invite people to contribute. So in that way, we are able to cover as many languages as you can. So for this phase of the project, we have been able to cover, I think, around 12, and if we add like the South African languages, it would be like 16 for South African languages. So yeah, we created 3 languages, and we used found sources for I think around 10 or 11 languages. So for created is like we go to the studio or actually record. And then for found is like we use an existing recording and convert it into like a data set that can be used to train a model. So for the 3 languages, those are all like Luo and Suba spoken in Kenya and Tanzania, and Kenyan English is spoken in Kenya. Yeah. And the others you could see like the distribution. So we try to like cover as many regions as we can. So yeah, just to talk more about like found sources or where do you get some of this data. So one of them is Faith Comes by Hearing, which is kind of like the source data for the Wilderness Project. And so they had like a lot of like recordings, gospel films and Bible recordings for a lot of languages. And so we use that, although we use that for Suba because that's like what we could find. But the license limits redistribution and derivative work. So we just show like the results and we show people how to do it for themselves, but we cannot redistribute it. And then there's Open Bible, that's like by Biblica. Again, it's also the New and Old Testament, the Bible, but this one is you can redistribute. So we share the data that we made from the Open Bible recordings. And then we have South African Center for Digital Language Resources. So we use this for the South African data sets. Yeah, so so there are kind of like stages that you have to go through to like create data, to like develop data from a found source. And the first thing is text normalization. This is mostly really, really important for Bible. There are a lot of numbers in the Bible. So you will want to normalize that. So from like the numerical form to like written out in the text, not text, but like, yeah, just write it out in like words. So, and then also, for that, we had to start a project for collecting dictionaries for numbers. So like, for example, this is how you write it in this language. And we were able to collect for a couple of languages, especially the ones that we worked on. And we're hoping that people can contribute for a lot of like other languages. And then also there are like missing segments or like modified. So like these are in situations where for example, what is in the audio is not in the text. An example would be someone saying the book of Matthew 1, while in the text, you just have like that you get from like the Bible, you just have Matthew 1. So you'll have to change that text to the book of Matthew 1 so that it is the same as what is available in like the speech file. So that requires some sort of like you kind of have to listen through that recording, and they can be large. So you can just listen to like a couple of them, just find common patterns of like common missing things and just add them in. We can write scripts to like automate that by like you have to kind of like listen to identify where is there like a place where there's like a recurring mismatch throughout this audio. And then also something else that also helped us is like on the text, you'll have to add like a new line in a way to just kind of like help the segmentation to be better so that you can produce higher quality and more segments from the large audio file that you have. So for example, like most Bible recordings, you'll have like a recording of just one web file of Matthew 1. So Matthew 1 is probably, I don't know, let's say it's 10 minutes long, and you want to cut it into like smaller segments, and these smaller segments should have like a corresponding like text. So we would go to like the text and probably add new lines around verses. That was easier. So in a way, we're kind of like helping the segmenter, the aligner, to like do a better job of like identifying the different like alignments. So after normalizing the text, of course, you're normalizing the text so that the alignment is done well. So the CMU Wilderness has like a whole tool for like doing alignment, which is like really good and produces like really good alignments. And so we were working on the New Testament, which is around, I think it's like 260 chapters, I think. That is like really, really long, and it takes time, and you're starting from like scratch, from zero, and trying to get that alignment done. And for most, like, I mean, different languages, like some languages are longer, like they talk more than others. So for like probably it took around 2 to 5 days to it can take less, but an average is like 3 days to align the whole of New Testament for a particular language. And then some languages like Lingala, it's really long, so it's probably took like 5 or 4 days, and I think that's because we're running so many things at the same time. But on average, you should expect it to be around 3 days. And then after you've aligned, so the result of an alignment process is you'll have like smaller files. So coming down from 260 files, audio files, to around 10,000 or 15,000 files. So from that, you need to like select. Of course, the alignment process is not perfect, and then the others which will be like not done well. So you'll need to select like the best 2,000 or 3,000, whichever you want to use. So far as we try to select you can score the alignment. There's a way to score the alignments, like, oh, this is a good one, this is a bad one. So we select the best of the alignment. So either the best 2,000, the best 3,000s of those, and use that as your data set. So that's the process for like the found one, which is a bit, but this is for created. So like, oh, I have a speaker, or I don't have a speaker, or we call them a voice talent. I want to record my voice, for example. So the first step is developing a prompt set. From the found data, you already have like a transcript. You just need to do like normalization, and then after alignment, select. But here you need to actually develop the prompt set. So that means you need to go out there and look for text. And then you need to select a speaker. So who's going to record this, and find a place to do the recording, or equipment to do the recording, and then record it, and then adjust the transcript. And I talk about, so adjusting the transcript is, so usually like after you have recorded, sometimes, almost all the times, what your voice talent will have said differs from what is on the prompt set that you selected, the transcript that you developed. So you'll listen to like the speech that you recorded and make sure you just change your transcript to match what the speaker said, so that you don't have mismatch in your data. So for developing a prompt set, we also discuss this in details in the resources that we've shared, how you can do it. It will start with getting text, and then you probably don't need all the text that you have found. So from the text that you have found, so if you found, like, for example, a 50,000 corpus, how do you select the best 2,000, the best 3,000, depending on how much time you have or you can pay for the speaker to record? How do you select the best of the text that you have to record? So we also discuss that Yeah, so I said we recorded Luo Suba in English, Kenyan English. So just a brief about like the two languages, Luo and Suba. These are all spoken in the western part of Kenya and Tanzania up. Um, so these are mostly like the regions that they're spoken about. Oh yeah, so yeah, I think this is just me like sharing like the lessons and the kind of things that we had to go through to develop the prompts for the languages. So for both of them, we had to go to the internet to look for data because there are a few places where you can just go and say like, hey, I need data for Suba. There are a few data sets that exist, textual data sets that exist for Suba. And then we try to look for sources, even as you're scrapping like the internet, look for sources that allowed us to redistribute. So we use newspapers, websites, we used books, research papers, and everything. And if we had to contact people to get permission, we tried to contact them to get permission to use the materials. And then we had to do what I talked about, normalizing. And then for these two languages, it was normalization was very difficult because of for both of these languages, as like the written history for these languages is like probably like maybe less than 100 years, so it's not really standardized. So it's a lot more difficult to like normalize it. And also they also do have dialects, so it's kind of difficult to do that because of that. And these are just how we obtain for Suba. Most of the text was from our website called subalanguage.com, where we have people putting in text and projects on how they want so Suba is an intelligent language, and they want to revitalize the language. And we got some text from social media, but we had to get rid of it eventually because most of it were from language learners. So when we took it to someone who speaks the language, it's like, yeah, I mean, this is most of it is kind of like not their try to speak Suba. And then so we had about 1,178 utterances that we used. And then for Luo, we had a combination of things, translations from like English, from Facebook, from also websites and other sources online. And then for Luo, we selected around 1,500 sentences. And we had to that we used. So for Luo, we had a total of 13,879 to choose from. From Suba, we only had 1,078, and we used it as it was. But for Luo, since we had a larger corpus, we chose the best 1,500. And then, so for each language, you have to choose a speaker. Okay, we had to choose a speaker, and it was particularly very crucial for Suba because like very few people can speak the language fluently and can read at the same time. So it was a bit, we had to advertise and ask people, hey, do you know, can you send us samples of you like speaking? And we were able to find someone who was recommended by somebody who's like an authority. So the person who we selected is a teacher, and he speaks the language and teaches the language. And for all of our speakers and all the people who participate in the process, we paid them. So either cash or kind. So for speech recording, this is like a really exciting and interesting part. So I think for Luo, it was recorded when I was in Pittsburgh, here in the US. For Suba, it was recorded when I was in Kenya, but I was in like Mombasa. So I was not in the same place at any given moment. I was not in the same place as the people who were recording. So we kind of had to do this virtually. And for Luo, we recorded with somebody, the voice talent, we recorded it in their house or somewhere in Nairobi. And we did it over 8 sessions. So every single day for like 8 days. And we would do around 4-hour sessions of just the person. So it was like me and the person who is recording, and they will record using they were using like AirPods to record, so just their phone. They'll just like read out and record, and we'll be on the other side just listening and like giving directions. So I speak the language, so I was able to be useful in the recording. So for Suba, we were very lucky because we found a radio station in Fangano Island that was willing to do the recording for us. So this radio station is a Suba radio station. So it was really important for us to like go there because these people speak this language. And so the speaker that we found lived on the other side of the lake. So when you see him in the picture there, he had to like take a boat to go to the island and do the recording over there. And so during the recording, we had to kind of like adjust the original script because like I was here, I don't really speak the language. I mean, yeah, my mom is Suba, but I don't speak the language. But I was like, yeah, I have this like really nice, it looks really good text. And when like I gave it to other people, they're like, yeah, it looks good. But like when Victor was recording on the series, they're like, yeah, some of this they're like right or something's wrong with them. So we kind of like had to like get rid of almost a third of the original script. And yeah, we were happy that he was in that position, like in that place to record because he was able to get that feedback. And he also gave feedback and was like, yeah, we think we should remove this because it's not quite right. And they were able to record it overnight. So one of the main challenges was like when I explained about fish and feast, so like what pronunciation do you want the person to use? Because some of the text had some, for example, you're talking about the text has something about like the name of an organization. Some of them have like English names, for example. And if you want like to deploy your model, like you would, if you are deploying to like Kenyans, for example, you would find people giving you text that have like mixed with like English. So what do you want like your model to do? Should they use like how like a Luo pronounce it, or should they use the English pronunciation? So that's for us when we're recording, just like they use the speaker to choose what is most natural to them when they're recording. How much time do I have? Okay. Yeah, as I mentioned earlier, so after finishing the recording, we modify the prompt set or the transcript to make sure it reflects what was actually spoken, and then we also had to do some normalization to the audio to also make it uniform and good. And for the English, Kenyan English, I recorded it on campus in one of the studios on campus. So it's kind of like similar to the recording of Suba. The text that was used for the Kenyan English was the CMU Arctic dataset. So with these like datasets, corpuses corpora that we've created, like we wanted to find out like a few things to enable us to achieve our goal. I hope you remember them from the beginning. So the first one was like, are the datasets sufficient to build a high quality synthesizer in the target languages? Remember, like for Suba, we just have like about, for both Suba and Luo, we have like 1,000 utterances. And how much curated data is necessary. So for Suba and Luo, like how much of that is really necessary? Because like CMU Arctic is, you could use like, I think it's around 500 or like roughly 600, but that 600 utterance, like it is like specifically designed such that every, I think it's like a triphone in English is included in that, but you won't be able to find that for African languages because this semi-Arctic was developed in conjunction with like linguists, and also like the English has these like lexicons that already exist for some of our African languages. Actually, most of them, we don't have like lexicons that exist already. And so we were just wondering like how much is necessary. You could have like 1,000 utterances, but they're probably like maybe less than half the triphones in that language. So we're just wondering like how much is really necessary, and then how does curated data compare to found data? How much is these like small data sets that we created in not like the ideal situations in either somebody's house with like their phone compared to, because for the phone data, they're usually recorded by professionals in studios, like really high quality. How do they compare? So to kind of like evaluate, we did like transcription test and A&B test. For the transcription test, we just ask after building our synthesizers, so our GTS systems, we synthesize some text, and then we ask evaluators to kind of write down what they're hearing and to compare with the original. Are they really, is our model, are our models like learning like the right thing? So if we checked if they're getting like what is supposed to, what's the right thing there. And then for A&B tests, we do this, we ask people to choose. So between the text, so for this, we only did A&B for Luo and Suba because we had data from both created and found. So we ask evaluators to choose the speech, the utterances that they like, and from that is created either by the model trained on the created data or on the model trained on the found data. Yeah, so for the evaluation, we just did the same thing, tried advertised positions, and then we had 2 evaluators for, I think, each language, just to check on that. And then we also had, we used this platform called TestVox that helps in running listening tests. That is, if you are doing any speech research, you should probably check it out. It's really good for running listening tests for your experiments. So this is how it looks like. So this is for the A&B test. So it's like shuffle randomized. You don't know which one came from which system. And then the user the evaluator has to choose which one they like. And for this A&B test, this is for Suba. We created like 3 systems, like from 25 minutes, 50 minutes, and 101 minutes. Remember, one of our goals was to ask like how much data is really enough. So we split all the data that we had, which was like, for the most that we had for the creators was 100 minutes. So we split it into like 3, so 25, 50, and 100. And then we create models out of those, and then we ask the evaluators to rate which ones they liked. And then, so like for Suba, we find that in like small, in like really extremely small, like tight durations, the created one like sounded better to the evaluators. But as we increased, we found that they liked the one from the found, which was like kind of interesting. And so like to kind of like summarize from the results that we had, are they sufficient like from this? And also I think for the results from Lo, we find that kind of they are sufficient. If you follow like the best practices that we followed, they are kind of like, and we used FastFox, they're kind of sufficient to create a high quality synthesizer. And then how much data is necessary? And the answer to that is like more than 25 minutes. Because less than 25 minutes, it's not worth it getting a speaker, setting up all those, setting up and getting ready to record less than 25 minutes. One, it would be worse, and 2, if you can record 10 minutes, you can record 25 minutes without a much additional cost. Yeah, so, and then how does curated data compare? with found data. So we found that when it is really small, curated data is better. Remember, we had like a lot of like best practices that ensure that we get like the best even out of the really small one that you had. And that might not be the case for found data, because found data is just, they're not, when they were building those data sets, they are not having TTS in mind. So they're just either building it for, they were recording it for Bible, for religious purposes. They're not recording it with like, oh, this data is going to be used to build TTS systems. That's why we find that curated data, even when it is really small, is better than found data. So in this current phase of the project, we are trying to improve the voices with different other ways. And also we are getting to deploy it, and we have different users. Like we have the end users who don't have access to the internet, they have smartphones or they have laptops, and then we also have developers who want to use it in the applications, and we have researchers who kind of need it for their research purposes, and we want to enable all these users to be able to use them. I think I'll stop in 1 minute so that we can have time for questions. And we cater to them in different ways. And African Voices website is up. I think our web hosting provider is like having issues. That's why it's down right now. Hopefully they can fix it soon. For those who haven't interacted with it, if it's up, I'll notify you guys, and then you can be able to interact with the website. This is how the website looks like, and it has all these features, and you can synthesize text. So you can just put text and it will give you back, and you can download the datasets and the synthesizers that we've built. Yeah, so we hope to add more languages, finish up with the mobile app, and improve the voices. Thank you very much for listening. Yeah, these are the various ways of interacting with us, and you can contribute that link, you can report bugs and request features for the website that you already have running. And you can also read the paper, because I just did a summary for to like engage more with like what was our process and our thinking throughout. So yeah, thank you. And yeah.
Thanks so very much
Yeah.
for this wonderful talk, Perez. So it's time to take questions. Do we have anyone with questions? So I can see on the chart, someone is asking, can we get this slide?
Yes, I can share with you guys. Yeah.
Hello.
Okay.
Hello.
Hello. Hi.
Good evening. It's evening in Nigeria. My name is Omar Adam. Joining from Nigeria. Like this is my research area. I'm a PhD candidate. My research topic is automatic speech recognition for Hausa language.
Yeah.
I've collected and deployed some data sets. So the question is that how do I get is your data set open source? If it is open source, how do I access the data set? And another challenge I've been having is the voice to text, the transcription, the alignment aspect for Hausa, since we don't have a pronunciation dictionary. What do you suggest I do in that very regard? Because it's part of the work where I have to like input the Hausa sound and also get the Hausa text. What's your suggestion on this very regard? I'm on the last stage, which is the speech recognition stage. And if it is possible, if I can reach out to you maybe after the whole discussion so that we can continue the conversation via email, I will be glad to have that opportunity. Thank you.
Okay. Hi, I'm going to try to answer as much as I can here, but we should probably link up after this. So is the dataset open source? Yes, it is. And it can be, you can find it on our website, which I'm sorry is currently down. We are currently having issues, but it will be up as soon as they have fixed it, so you can download it, and you can also download our synthesizers. All the datasets we created, apart from the Super one, which because we created it for Bible.is and they don't allow redistribution. And then you're asking about how is alignment. I think for most languages we don't have like a dictionary for one dictionary for them. But I think what we did, what we did for that is we used the grapheme version of FirstVox, and that's really why we used FirstVox, because that way you really don't have to have like a lexicon. If we had just another setting or like other methodologies available out there, it might have required us to have a lexicon, but because one, we didn't have it, and two, we don't have the expertise and probably the money to pay the experts to build a lexicon for us, we decided to use like the grapheme version to build our models, which it worked really well. And then for alignment, if you wanted to like do alignments, I also mentioned that FirstVox has this tool that does the alignment. It's like a combination of like machine learning models that does that alignments from cross-lingually, like from scratch. I can share that with you. And I think I also have like code to kind of do that. So we should link up and I can share the resources with you.
Thank you so very much for that wonderful answer and the wonderful question. So we have other people right on the chart with some other questions. So someone is asking, how did you deal with frustration at different stages of the process?
Yeah, that's a good question. Yeah, the process sometimes it was really frustrating. I think, throughout the entire time I was learning while doing it, because it was like, it's my first time like interaction with like text to speech. So I'm learning while doing. So obviously for that, you just have to be patient and keep trying and reading and asking questions. And then the other frustrating part was like the recording part was like frustrating because we're not in the same place. They have their challenges. The people who are recording have their own challenges, and also like the logistics involved. Again, I think I was just like patient and understanding, and like you just communicate well with like every stakeholder who is involved and express like your frustrations and find a way to get a solution. But it's really hard, especially if you are not in the same place as the people who are recording it for you. It can get really frustrating at times, but you're just trying to like understand each other and work towards like the common goal that you all have can just help. And just being patient, I think overall just helps.
All right. Thank you so very much for that answer. So we have another question. We have many questions now. So what do you think were the strengths of your application of LTI?
My application of LTI, do they mean my application to my master's program? Oh, I'm not sure what they mean. If it's about like the strength of my application, it's something I don't think we can talk about here in like a few minutes. So also just reach out to me via LinkedIn. I think you can just send me a message and we can
the person is asking concerning your master's.
Yeah. So they can reach out to me and we can talk about it.
Okay, so you can reach out. Is it Laundry something Shesta? Sorry if I didn't pronounce that name well. So you can reach out to Perez on LinkedIn. You search for Perez, and then you can discuss further on the question. All right. So we have another question here. The speech also generated by using JavaScript only within the browser. How big is the model?
Okay, good question. So We have the models on our back end. So we have the models on our server. And when you interact with our website, you're basically sending text to us and we're generating, and we are sending you back the audio files. But on the website, as I mentioned, you have the synthesizers too. They're not very big. I don't know the exact size, but they're not big. Can they be? I don't think they can be more than like 50 MB. I'm not sure, but yeah, you'll just download them and you'll be able. You can use them. The thing is, like, they're small enough for you to download it on your phone or on your computer without like having any issues. And that's why we used Flight, because of that accessibility. You don't have to have either powerful machines or like big memory to like download them and use them. Exact sizes, I don't know, but you can check that on our website.
Awesome. So thank you so very much for the answers and the questions. Do we have other questions? I think this is just the last question I can read from the chart. So we can unmute ourselves if you have questions, so we can just ask questions. All right. So for me, I have just, should I say one question? I don't know. So my first question is, how did you deal with noise in the data set? Like the background noise. You know, one of the challenges of linguists over time is to create a software that would dampen sound, even though we use Pratt. So, for example, as I'm listening to this this talk, I can pay attention to this talk and kind of deaf myself to background noise, right? But machines cannot do that. So, how did you pick your your content? So, I think you focus on Bible, right?
Yeah, that's for the found data. For the
Yeah.
creative data, yeah.
Yeah. Okay. Good. So now, so how do you do for the ones you recorded? And that's the
So
number one question. So the second question is, you did some linguistic analysis.
mhm.
Yeah. So what kind of linguistic analysis did you do on your data set to prepare it for your project?
Okay. Thanks for the question. So the first question of how do we deal with background noise? I think it's very important to try and avoid it as much as you can. So for those which were recorded in the studio, it wasn't really much of a problem because obviously the studio is it's like quiet. But for the lower one, which was recorded in a house, you really can't control what your neighbors are doing and the roads and everything. So there's obviously going to be some sort of like background noise. And even if you look at the paper and listen to the audio that we recorded and the resulting like models, you'll see that it kind of affects the quality of the model that you have. So for what we tried to like record in times where there'll be the least noise and interruptions as much as possible. And after that, there's really nothing much you can do to kind of remove the noise without distorting. So we didn't do any other, apart from like power normalizing it to make the volume kind of like uniform. We didn't do any other further like modifications to the audio file of the recorded data that you have. So we used it as it is. So that's why we encourage people to kind of like try and find a quiet place. And we still also build models with the one that is like, no, it's not like zero background noise. Still to find out like how does it compare to the studio one, which has like almost zero background noise. But we found that they are comparable. So yeah, the best way to deal with background noise is avoid it in the first place. For the second question about like, the linguistic analysis, did you do any? Yeah, for Luo, yes, we did. So it wasn't, I don't know if it's linguistic, I'm not a linguist. I don't know if I would call it a linguistic analysis, but it's kind of like a way to find out the most diverse. Remember, we don't have like a pronunciation dictionary for Luo, for example. So we try to like find the most, looking at just like the orthography and the graphics, like trying to find like the most diverse sentences, the minimum size, like the minimum text that we needed to find like the most diverse different like combinations of like text, so that we can maximize our chances of including as many fonts as possible for that particular language. And that is easily done when you use like the Festival suite of tools that they're able to do that just using like the in a grapheme way, because you don't have obviously a pronunciation dictionary. So that's kind of like the linguistic thing that was done. Otherwise, it didn't really do much on that, because you also like try to our like whole like process and pipeline, we try to make it as easier as possible for somebody like who is not a linguist or a linguistics expert, who is not like a machine learning expert or a computer science expert, to be able to do it and build it for themselves. So yeah, that way like they can replicate our process without like needing a lot of help. Yeah, I hope that answers your question.
Yeah, thank you so very much for for those answers. They are really nice answers. Thank you very, very much. So, well, I wanted to probe further, but I don't want to take much of the time because I'm really curious about the linguistic analysis because I have been with AI experts, purely computer scientists, and I feel that there is a way we could go from speech to phoneme to phoneme, then phoneme to speech, so much that you have a kind of you have the phoneme as a transliteration in quotes, so that if we have that, then we can have millions of languages translated to the phoneme rather than the grapheme where we have the difference, because R is R. So if you can recognize R, then R is written differently in different languages. I don't know that I get my point.
Yeah, I get it.
Yeah, I is still, but then if we have it phonetically, I mean by phonemic analysis, then you have R's the same thing all over languages. So, for example, if you are dealing with Luo, you're dealing with Hausa, you're dealing with Yoruba, then you can have R recorded, and R can serve different purposes. But I don't think there is any direction, any research in that direction. But there is a way we could use IPA to write it, so to be like a universal uh, text. So from there, now you have different languages that are liable to speak or to use such textual analysis. I don't know that you get my point, but for the linguistic analysis, I think you did a very wonderful job. Thank you so very much, Perez, for this talk. I hope to get in touch too, at least discuss some things on linguistics. So yeah, wonderful talk. So do we have any other comments or questions, suggestions? Okay, so Umar is asking another question. What tool did you use for speech segmentation?
So the tool that we use is provided as part of like festival. You can find it on CMU Wilderness. If you just Google CMU Wilderness project GitHub, you can find it there. And I think also in one of our GitHub repos, I have a script that you can just, because you'll have to do a lot of some modifications to like the default one found on the project. But I think I've released a script that you can use to run like yours or any other from now on. Yeah, so it's kind of maintained by my advisor. So for me, I had that help if I was getting like bugs or like stuff issues with it. I could just go to him because he's one of the main people who developed it. So I could just go to him and get it fixed. So the one that I'm using is probably like the latest version with no issues. So I've released it in our website. So just check on the link on the slide that I shared and see if you can find it, and instructions on how to use it are all there. Yeah.
All right. Thank you so very much. Blessing, I don't know, did you put your hand up?
No, I didn't put my hand up.
All right then. Thank you so much. Okay, so if we don't have any other question or comments, thank you so very much for this talk, Perez. We are really happy to have you here. Thank you everyone for joining us, and then we'll be closing for today on this note. So we will meet next 2 weeks on the same channel, on the same organization, should we call it. So we'll be meeting in next 2 weeks on Lanfrica Talks. See you next week.